Alright, here we go. Algebra 1, Chapter 2, 5, Absolute Value Equations. Lots of fun here. Absolute value, the distance of a number from 0. Okay, remember, a distance can never be negative, so absolute value is always positive. If we look at this on a number line, here's 0, and 5 units away from 0 is positive 5. Well, also 5 units away from 0 is negative 5, which means the absolute value of positive 5 is 5, but the absolute value of negative 5 is also 5. The distance of a number from 0. So if we have the absolute value of m equals 7, then if I find 7, the distance from 0 to 7, that's 7 units. However, also 7 units away from 0 is negative 7. So this problem, this equation has two solutions. M equals 7, that's the absolute value of 7, and m equals negative 7, because the absolute value of negative 7 is also 7. So when solving absolute value equations, you have to consider both the positive and negative possibilities. Evaluating an expression isn't necessarily difficult. We just put in the 4, plug in the 4 for m. You get 4 plus 6. And then evaluate first what's inside the absolute value bars, because that's a grouping symbol. The absolute value of 10 is positive 10. 10 minus 14 gives me negative 4. If you have an equation, however, remember this expression right here, this can come out to be positive 17 inside there, because the positive 17, absolute value of positive 17 is 17, and the absolute value of negative 17 is also 17. So we always have to look at two cases. So when I set this up, I'll do my positive over here, and then I'm going to consider my negative on the other side. So f plus 5, either f plus 5 is 17, this inside here is positive 17, or f plus 5, this expression inside here, comes out to be negative 17. Both of those would fulfill this statement. So solve each the same way you would solve any equation. Get the variable by itself. Then I either get f equals 12, which if you plug that in, 12 plus 5 is 17. Absolute value of that is 17. Or f is negative 22. Negative 22 plus 5 is negative 17. Absolute value of that is positive 17. If I am to graph this, make sure you're reading the instructions closely. If it says and graph, that means find those points on a number line. So I'll find 12 on the number line, and then negative 22. And that's the graph of this. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit. Give or take 5 degrees Celsius, 5 degrees Fahrenheit. Yep, we're seeing that right here. Find the maximum and minimum temperatures. So give or take, that implies an absolute value. That means 5 more than 80. I find that number on the number line. 5 more than that would be 85. And 5 less than that would be 75. So the maximum temperature is 85, the minimum is 75. Writing an equation involving absolute value. If you're given a graph like this and you have 2 points, remember absolute value is always the distance from a point. So I'd want to find the midpoint of these two. That midpoint is 15. Each of these points is 4 units away. That means the absolute value here is 4 units. So the absolute value of something comes out to be 4 units. Well, I've got to involve this midpoint. What I'm going to do, if I wanted to find how can I get to 4 units? Well, I have 19 and 15. 19 minus 15 is 4. And down here I have 11. 11 minus 15 is negative 4. But the absolute value of negative 4 is also 4. So I put that in absolute value bars and write that equals 4. So I start with a midpoint. X, some number, either 19 or 11 is what it's going to be, minus 15 equals the distance right here. And that's it. Like and subscribe, ladies and gentlemen. And don't forget to hit that notification bell like it's your business. Comment when you're done.